we're talking about demand, and I think at the end of class last time we were talking about, well, let's think about a polar case where each person is going to decide how much of a good to buy, and in particular a case where they only buy 0 or 1. It's called a discrete choice model, and this is the simplest discrete choice model, is whether you either do or you don't. Right? It's just yes or no. That's it. That's the only choice you have. And I tried to explain last time, a lot of things that look like 0, 1 really aren't 0, 1, right? They're really like continuous as long as you look at them in the right way. Like we said, haircut. Getting your haircut's like 0, 1. You don't go in the barber and say, I'll take 2 haircuts, right? That don't happen. But the question is, it's easy to think of as a continuous choice if you think about how often you get your haircut, right? I either get a cut once every 28 days or 27 days. You could even get it down to the minute if you wanted, into how frequently you got your haircut, right? And that I don't think is useful to think of a discrete choice problem, right? People see why thinking about a haircut as a discrete choice is really not the right way to think about the demand for haircuts, because it is really something for which people can vary continuously without even talking about quality, just talking about frequency. It's just, and it's the kind of good where you don't really consume the haircut anyway. It's like, how well groomed do I want to stay, and how often I cut my hair is something telling me how well groomed I want to be. So anyway, but no, let's think about a good that really is, you want to be 0 or 1. And we can think about each person as having a cutoff. And that cutoff we can call VI for person I, is the value they place on this good in dollars. So if this is the price, and this is the quantity, we could think of their demand curve as kind of looking like that. Really, the parts that are really well defined are kind of this part. And then you can either think of this as horizontal, or you can dash it in, whatever you want. In keeping with our model, you really can't choose anything in there. So at VI, we'd say you're indifferent. You're indifferent between buying the good or not, right? That's what we mean by indifferent. And it's easy to see, why that would have to be the case, right? Because if you were, if these things are kind of continuous in income, as long as they're continuous in income, you're going to have to be indifferent between those 2 points, just as well off one point or the other. Now you could think of VI as you could either think about it as the guy's true value, or you could just think about it as a choice, like we were saying before. Just think about it as an empirical value. This is the value at which he'll move, right? And we're inferring his VI, right? You could think about it either way. We can either say, look, this guy has value VI, and given he has value VI, this should be his demand curve. Or we could say, this is his demand curve. This is how I see him behave. And given that, I can infer his value as VI. Right? Those are just 2 ways of looking at the same problem. One's kind of saying, if I adopt the theory, this is how he'll behave. The other is, given how he behaves, this is how I will interpret it in terms of value. Okay? All right. So that's his demand curve. So then you might think about there being a distribution function f of v equals the probability that VI is less than or equal to V over some population. That is, the fraction of the population that has a V less than or equal to VI less than or equal to V. Right? It's just the cumulative distribution function of V in the population. Okay? So the demand D of P would be equal to what? Well, D of P, the amount that would be demanded at price P, would be the number of people in the population times 1 minus F of P, because everybody who has a V bigger than or equal to P is going to buy, let's say. If this is not a continuous distribution, then you really got like a bunch of people are indifferent. But let's just assume F is a nice continuous function, If it's continuous, then this formula will hold. That will be the fraction of people that will buy. This is the fraction of people that buy. That's the fraction that have V bigger than or equal to P. And then we multiply that times the number of people, and that gives us the total number of people who want to buy. Any questions that people have? Okay. Now, if you thought about this V having some kind of like normal distribution, right? Let's assume that V had a normal distribution, just to think about what that would imply. We don't have to, it doesn't have to have a normal distribution. What would this demand curve look like? What would this demand curve look like? Well, remember, our demand curves are all drawn kind of backwards because we got P on the vertical axis and quantity on this axis. So it would look like this. Well, I guess, yeah, so it would look like, it looks something like that, right? If it was a normal distribution, where this would be asymptoting to what? What would it be asymptoting to? 1? N, right? This would go to N. Be asymptoting to N. And if it was normally distributed, some guys would actually have negative V's, of course, which means they don't like the product. You know, if you don't like a normal distribution, you could take a log normal or any other cumulative you want. What if it was uniform? What if the distribution of values was uniform? V is distributed uniform on some interval A to B. What would it look like? Well, above B, nobody would buy, right? Below A, everybody would buy. So we just have a nice linear demand curve. That would be the demand curve where that would be N, right? That is, if you get below A, everybody's going to buy. Above B, nobody would buy. So we'd have a linear demand curve. So one way people motivate a linear demand curve is some sort of uniform distribution of preferences. Okay? Now, if you think, well, what's the elasticity of demand? If this is the demand function, what's the elasticity demand? Well, the elasticity of demand would be partial d of p respect to p times p over d of p, right? That's the elasticity of demand. Would be equal to p over n1 minus f of p. And then the derivative in, what's the derivative of 1 minus f of p? It's just minus little f of p. So that would be equal to minus, there's an n there, n's cancel. So minus p little f of p over 1 minus f of p. Okay, that would be our elasticity. And so the elasticity of demand sort of depends on how many people there are on the margin relative to how many people are already buying, right? This is the fraction that are already buying the good, and this is how many people are on the margin. So if I'm at a point that's a very high density, where there's lots of people, that's going to tend to be a point where demand is relatively elastic, right? Everybody understand that? That is, the elasticity of demand compares the fraction of people, the number of people on the margin at that price. That's how many people are, that's the height of the density, and that's how many people are buying already. So it's how many people you have on the margin relative to the many people already buying. Okay? And so if we had a demand curve that looks like this, what you'd see if you, for example, had a new good that came in with a really high price, hardly anybody would be buying. As prices came down, maybe the number of people buying wouldn't go up very fast. But then when we get into the meat of the distribution here, there'd be a big increase in the number of consumers, right? You can think about this as kind of like an adoption curve, having nothing to do with network effects. Later we'll talk about network effects and how network or bandwagon effects can create this kind of big elastic response. This is more just like saying, look, at very high prices, only people who really like this product are going to buy it. As prices come down, we get an increase in consumption, And that increase in consumption is going to get rapid if we get to a point where there are a lot of people on the margin, a lot of consumers coming in. One useful way to think about a model like this is, for example, to think about differences in income and think about the income as they're differentiating this willingness to pay. This is a normal good. The willingness to pay is rising in income. And if I had an income distribution, that could trace out this demand curve. And what we'd be saying here, if we get into up high, only the very rich people are going to be buying it. There aren't that many of them. And even as you come down and cut the threshold, maybe not that many come in. But when you get to the middle class, when there's a lot of people, maybe this is going to grow in popularity very quickly. So we can see a very elastic response. And it might look like this is like catching on, like it's a fad or something like that. But it really just has to do with the fact that all these people are basically in the same spot, and they're all basically making the same decision, right? So what happens is goods get cheap enough that they become something that the middle class wants, and then the consumption rises very quickly. You know, so that might be a good model for something like household appliances or things like that, where you might say it's not so much bandwagon related or network effect related. It's probably operated, for example, in the growth of the cell phone market, that one of the things that happened is they became cheap enough that the masses could afford them. On the other hand, I think if you want to study the cell phone market, you wouldn't want to ignore the kind of network side of the cell phone market, that if my friends have a cell phone, that makes it more attractive for me to have a cell phone. So you might be able to make some mileage just with a simple model like this, but probably for something like cell phones, you'd want to add in that additional impact that would come from kind of the feedback effects from having other people come into the market, making me want to come in. Some kind of network effect. Okay, kind of similar to what we've talked about on some of the problems. So Q equals quality. So people are going to decide they're only going to buy one unit, right? So they're only going to buy one, but they get a choice of what quality they're going to buy. Now, there's no reason we couldn't have them choosing multiple units and even multiple qualities. That's an okay model. It's just complicated. So I want to analyze the quality question, so I'm going to simplify my demand specification by assuming what I did here, which is 0 or 1. You're only going to buy one. Think about it. The guy's going to go in, he's going to buy a TV set, and he's deciding what quality of TV he wants. You can think for now that quality is just this unidimensional thing like how big the TV is. And he's deciding, am I going to get a 47-inch TV, a 50-inch TV, a 65-inch TV, a 75-inch TV, an 85-inch TV, 100-inch TV, whatever it is. It's the dimension of his TV. And I'm going to act as if, again, for keep my life simple, quality is a continuous dimension. So you can choose any size you want. You can choose 50.973 inches if that's what you want. Now, that's an unrealistic model as a description of reality, but it's going to be a nice one to work with because it's going to make things kind of simple to talk about. So we're going to think about individuals having indifference curves over the quality of the TV and the price that they pay. Right? So that's going to be his specification. Okay? So you might say, well, geez, price, how does that go in the utility function? So think about if you started with a utility function, that you had U of, let's call it X in Q, where X is other goods. So that's like all other goods combined, right? So X is the amount of other goods I consume. Let's just set PX equals 1, kind of a very natural assumption, right? If I'm just going to lump all the other goods together, I'm just going to make them the numeraire good. I'm just going to assume X has price 1. I'm going to let M be your income. So then, of course, your budget constraint is X equals M minus P, right? Right? Everybody agrees with that. That is, the amount of X I get to consume is how much I didn't spend on a TV. right? I got M to spend. I spend P on my TV. I get X left to consume. So then you just plug that in. This is equal to U of M minus X. I'm going to say M minus Q. I'm going to say M minus P in Q. And so that would be my utility function over P and Q. Right? And that's going to have some corresponding indifference curves. Now, a common assumption that people make is what people would call quasi-linear preferences, which is U of X and Q equals X plus V of Q, or something like that, right? That is a common form they take, which is basically to say I got a constant marginal utility of income because it's linear in X. And then it's really easy because then what you do, this is equal to M minus P plus V of Q, which implies pick Q to maximize V of Q minus P of Q, where that's the market price for quality Q. That's how much you pay for a good of quality Q. Right? Because you're going to maximize the value less the cost of the TV. Okay, so that would be a simple model. Now that has the unattractive assumption that quality is not a normal good, right? If you assume this utility function, you're going to get quality is not a normal good. That is, M doesn't matter for the choice of Q. Whereas if you go back to a more simple, more general utility function like this, if you make Q normal, then you'll get the usual kind of result that Q will be a normal good in this dimension, right? So quasi-linear is the most popular model that people use. But as a descriptive model of behavior, it's probably not going to work out real well if you're trying to understand differences by income, because we know income is generally a pretty good predictor of quality. Why is income a good predictor of quality? Why do people, as income goes up, consume higher quality goods generally and not just more? Yeah. Well, yeah, but more generally. There's some sort of physical constraint out there, right? That is, whether it's the amount of food you want to eat or how many movies you can watch at the same time or whatever. Right, there's some kind of physical constraint. So one way to think about the world is quality. Why would people go up the quality ladder? Why wouldn't they go up the quality ladder even when they're poor? Just by a little bit of the high quality one. How would you think about modeling that? Has anybody got a good model for thinking about that? I mean, think about if you had a model that says utility equals U of X, comma. Now, I assumed you could only buy one unit, which kind of forced you to go on quality. But let's say you did something simpler. You made this N times V of Q minus, all right, or plus lambda M minus X minus N P of Q. If you did that, what do you think people would do if you had that utility function? How do you think people would behave if you had that utility function? Right? This would be like I'm buying n units of this good. Cost is a function of quality, P of Q. Well, look at it. Call this Z. Okay? Z. Okay, now how would you express the budget constraint as a function of Z? So this would be U plus U of X comma Z plus lambda m minus x minus, well, put this in terms, I'm going to need n times v is going to be z. So I'm going to put it z times p of q over v of q. Right? Right? Everybody agree with that? That would be my budget constraint. What would that predict about q? What? What? V of q? No, but think about it. What does it mean? How would it vary with stuff like income or preferences? Like, how would it vary as u changed? How would it vary as u changed? Or as m changed? What would you have an incentive to do? Wouldn't there just be some q star that would minimize that ratio? That would be like the efficient quality level, right? That is, there would be a q star that would be the efficient quality level. Everybody would say, geez, I'm just going to buy this thing in the most efficient units, right? Everybody would be out there saying, you know, there's an optimal size, and then if I want more, I'll just buy more of the optimal size, right? There would be an optimal size or quality of the product, and the rich people would buy just more of that optimal quality, and the poor people would buy less, and the people who really liked the good would buy lots of the optimal quality, and people who didn't like the good would buy very few, right? There would be just this optimal quality. You know, you could think about it as, you know, that's what people are, you know, they would say, well, I'm trying to get something out of it. What gives me the most? What's the most efficient consumption I can engage in? So according to my question from before, you have to get out of that model somehow, right? Now, one view of the world is that, well, there's kind of the cost, there's a limit on n, right? That would be one world. One world is there's just a limit on n. There's a constraint, like n less than or equal to n upper bar, right? That is, you just have a certain capacity in your stomach. Think about this as like eating, whatever. There's a certain capacity, and once you hit the capacity, more generally, you just need some rising cost. Then you have a nice way to think about it, because what's going to happen as your income goes up? Well, you can't just buy more of the more efficient stuff. So you're going to have to get pushed up the quality ladder. That is, you're going to have to get more satisfaction by actually cutting back and actually buying goods that are more cost per unit of whatever this thing provides. And that would be a simple way to do it. And that's a useful model, I think, for thinking about quality. That people go up the quality ladder because there's some kind of physical constraint. Maybe it's stomach capacity. Maybe it's, you know, time in the day. Maybe it's, you know, the number of cars you can drive at the same time. It's all that kind of idea, that there's some physical limit that would then force you to buy things that cost more per unit of productivity. And the reason you need that, or something along those lines, is because you have to explain why the poor people don't just buy less of the higher quality good, right? They don't. That is, you need some force. And this isn't the only way you can model it, but I think it's a nice way to think about modeling it. There's some sort of physical constraint. So if that's the price quality spectrum, what do preferences look like? Well, in general, people prefer lower price and they prefer more quality. Now, the reason this is, remember last time when we did the demand curve, we had this like curve? Remember, that price was price per unit. This is the total price you pay. So clearly, your preference here is always lower price. And given the price you're paying, you want more quality. If I had put price per unit quality on this axis, then we'd have that U shape. But in this world, I'm going to think of my indifference curves looking like this. Now, I will tell you, there's no reason these have to be concave, because I haven't defined the units of quality. But I'm just going to draw them concave because that makes my life easy. And assume I've measured the quality space so that they are concave. I've just chosen my quality dimension, and everybody's indifference curves are concave. It's not going to matter. I'll explain in a minute how it's going to, why it would, what we really need. But that's the quality, that's people's preferences. What's clear is they always prefer this way, right? They prefer lower prices, they want to pay less, and they want to get more, right? That's easy. All right. Now, I'm going to have to, in order to talk about a market, I'm going to have to put in the supply side of the market. And I'm going to also have to think about how consumers make their decisions. And we're also going to have to think about what we mean by an equilibrium. So let's think about how we're going to describe consumer behavior. So the idea is the consumer is going to go down. He's got his preferences, Q and P. When he goes down to the store to buy his TV set, we're going to think about there being some kind of P of Q, which is the market price as a function of quality. And since everybody prefers more quality to less quality, this function is going to have to be upward sloping, right? If there were downward sloping segments, we could ignore them, right? Nobody's going to choose a point where they can get more quality at a lower price. So we might as well assume the equilibrium one is upward sloping because we're never going to be anybody located on the downward sloping parts. We would never see the downward sloping parts. They would be missing from our data. And he's going to choose a point where his indifference curve is tangent to this price line from below, right? This is what I'm saying. If his indifference curve was convex, then the price line would have to be even more convex, right? So his indifference curve always has to be concave relative to the equilibrium price line. So if I change the units in which I'm measuring Q, like square it or take the square root or cube root or take logs or whatever, this curvature is going to move around, but this one's got to always have to be less concave. They could both be concave, they could both be convex, but the choice point is always going to be a point where this curve is concave relative to the price curve. Okay? That's the idea. Right? So he's going to choose the quality level that maximizes his utility subject to the price-quality trade-off that exists in the market. Okay? And if we looked at the slope, therefore, of the price-quality trade-off, we could get a measure of his marginal willingness to pay for quality. Right? That is, we would know how much this consumer is willing to pay to get a little bit better TV set by measuring the slope of this price-quality trade-off. Right? Right? He's buying that 50-inch TV. We know how much it costs to buy a little bigger one. We can figure out his marginal value of having a slightly bigger TV. Okay? All right. Any questions that people have? Okay? Now, let's start thinking about the other side of the market. I'm going to do a real simple model of the other side of the market. I'm going to assume that there are producers on the other side of the market, and there are a large number of producers. And for right now, I'm just going to assume that the unit cost of production equals C of Q. That is, the cost of producing a unit of output is C of Q. And I'm going to actually make my producers just like my consumers, is that the producers are only going to produce one unit too, right? That's less essential, but I'm just going to assume that for now. Each producer is going to choose, they're going to produce one unit, and they can choose what quality they're going to produce. All right? And for now, I'm just going to assume there's a ton of potential producers, all with the same cost, C of Q. Okay? So let's let N equals the number of consumers M M equals the number of producers and I'm going to assume M is bigger than N, okay, just to make my life easy. I'm going to assume that there are more producers than there are consumers. And why? What does that imply? What am I going to know once I know there are more producers than consumers, and each producer gets to choose whether he wants, whether he wants to produce? He can choose 0 if he wants, and he has cost C of Q of producing quality level Q. If I have more producers than consumers, each consumer is going to buy at most 1 unit. Each producer can produce at most 1 unit. What's going to happen? What happens once I know M is bigger than N? What? Well, no producer. I mean, it's more than that. There's excess supply of producers, right? Some producers aren't going to produce in equilibrium, right? Because if they did, some of them wouldn't be selling, and if they weren't selling, they'd be losing money. So some producers are not going to produce, which means those producers are going to earn 0 profit, which means the producers who do produce also have to earn 0 profit. So competition among the producers are going to imply that profits equal to 0. That is, producers don't make any money, which implies P of Q got to be equal to C of Q, right? That is, the price you can charge for quality level Q has to be equal to C of Q. You can't charge any more than that, otherwise people would make money. You can't charge less than that because then you would lose money. So the only prices that could exist in this marketplace would be equal to the cost of production. So if I assume, now I can redraw my picture, same picture actually. I got Q, I got P. I got P of Q equals C of Q, which is pi equals 0. It's my 0 profit curve. And then where's my consumers going to go? Well, my consumer is going to choose the quality level that makes him the best off. Q star and P star. Okay. So that would be my choice. That's where the consumers would go. All right. So what would happen in a world where all the consumers were identical? What would happen? What would I see? What would the store look like in a world that looked like this where all the consumers were the same? Yeah. Yeah, we actually wouldn't see this P of Q function in equilibrium. We would only see a single point. You know, you'd go into Best Buy and it would just be one TV, right? It would just be like the old communist days. It'd be like the one TV. This is the people's TV, right? You go in there, and that's the TV you get. You know, so you know that would be the TV that you get, right? So that would be the TV that would be there. All right. So if everybody was the same, it would look like that, a single point. Now, question? No, okay. What if people were different? What if people had different income levels? What if there were 2 kinds of people? That is, low income and high income. Yeah. Okay, so what do the indifference curves look like for a richer person? Well, like up here? They're going to be steeper. That's the key. Through any point, they're going to be steeper. Right? That's what's important. That is, their indifference curve is going to get steeper. at a given point, right? They're going to cross through the other guy's indifference curve from below. They have a higher preference for quality, which will come out if they're a normal good. You should verify that. If they're a normal good, their indifference curves will be steeper, and they'll be tangent, therefore, over to the right, right? That is, they'll be tangent to this curve to the right, and if there were a whole bunch of different kinds of consumers, like you said, you'd trace out this whole cost curve. You just trace out that cost curve because different consumers would come into the store and buy different TVs. And these producers would sort themselves out, supplying different quality TVs, all making the same profit, 0. Some of them making high quality TVs, some of them making low quality TVs. So heterogeneity on the consumer side would push people to choose different points along this single producer's cost curve. This would be a very simple notion. Now, the price differentials I see in equilibrium would at each point represent that consumer's marginal willingness to pay for quality, but would trace out the producer's overall marginal cost of quality, right? The slope of this curve is the marginal cost of quality. So at each point, marginal cost equals marginal benefit for that person. But along the entire curve in this case, we'd be capturing the marginal cost of quality. All right, so I was talking last time about preferences and what happens when you have a quality dimension. And I think we only did one example, I think, right? We did all firms were the same. So this was C of Q, which is the cost function to the firms of producing a unit of quality Q. And then we said, well, if you had different consumers, those different consumers might sort out along that cost function, right? That would be the case. And then you might observe different qualities in equilibrium with corresponding different prices. Now, if we were to say, okay, well, that's two different consumer types in one type of firm, then you might say, well, what if we changed the problem and had two types of firms and one type of consumer? So you might call this C1 of Q, and this one would be C2 of Q. And then if we assume that there was free entry of both types of firms, that there was enough firms of both types to serve consumers, then what would the equilibrium look like? What would the equilibrium look like? We assume all consumers are the same. There's tons of potential firms of type 1 and tons of potential firms of type 2. What would the equilibrium look like? Yeah. Would we see more than one point? No, there's only one kind of consumer. Remember, this was two kinds of consumer, one kind of firm. We got this picture with 2 points. Call this UA. This is UB. So two types of consumers, A and B, one type of firm. Yeah, unless it's a knife edge situation, right? We would end up with, maybe that one, maybe it would be tangent here, I don't know. We would end up with a single point. There's no reason we would have to end up with an equilibrium in which people are buying from both types of firms, right? That is, profits would be driven to 0, and whichever firm could satisfy consumers' needs at the least cost would be the one that would survive. It's kind of like when I did that thing last time. You'd minimize cost per unit quality, right? You'd just be finding the most efficient producer of quality, and from these consumers' perspective, they would all choose the same firm. And the reason is we have free entry of both types. There's no reason. Why didn't we get that over here? Why didn't this degenerate to 1 point? Because we didn't have free entry of consumers, right? We just had consumers of both types. It wasn't like the consumers could choose which type they were and then choose the one that gave them the most utility. If you did that, then they would choose one of the type or the other. There's no reason people would choose different types. So that's the big difference. Often when we think of firms, we think about free entry, and when we think about consumers, we don't. Right? We don't think about there being free entry of consumers. If this was a world in which people could freely migrate, you might think of free entry of consumers. You might say, look, consumers are only going to come in to some point. What would happen if there was a limited supply of one of these firms? So let me assume for the moment that the number of ones plus the number of twos is greater than the number of consumers, but the number of ones is less than the number of consumers. And I'll make it simple. The number of twos is also less than the number of consumers. What would happen in that case? There are more firms out there. Remember, each firm only produces one unit. Remember that, right? Each consumer is going to consume at most one unit. Each producer can produce at most one unit. Let's assume that there are less producers than firms. Less producers than there are consumers of either type. But totally, there are more producers than consumers. What would the equilibrium look like? Yeah. Okay, so take my picture I just drew. What would the equilibrium look like in that case? Two types of equilibrium, or would there be a unique equilibrium? There would be a unique equilibrium. What would it look like? Well, let's think about it. These guys, in the way I drew it, consumers would prefer, if they're earning zero profits, to buy from firm 2, right? So the firm 2 clearly is going to exist in equilibrium, and all the type 2 firms are going to work or be in equilibrium. But we're going to need some type 1 firms to also come into the market to serve some of the consumers that will spill over, right? So we know these guys are going to earn zero profits. So you could take this C1 of Q, right? That would be the cost of the type 1s. The consumers are going to have to be tangent to that, right? Everybody agree? This would be, call that Q1 star, P1 star. So the type 1 firms that exist in equilibrium will earn zero profits. This will be pi equals 0. Okay? Right? Everybody agree with that? That is, some of these type 1 firms will not produce in equilibrium because there's more firms than consumers. So some of these guys are out. The guys who are out earn zero profits, and therefore the guys who are in have to earn zero profits, right? That's what competition would do. Competition would force the type 1 firms that survive to earn zero profits, just like the type 1 firms that are out who earn zero profits. You just can't have an equilibrium in which the type 1 firms are making money, because all the other ones would want to come in and bid that business away and push the price down. So that's one point that's going to exist in our equilibrium. Now, the constraint faced by the type 2 firms is what? They can't make the consumers any worse off than the type 1 firms. Otherwise, the consumers would run over and buy from the type 1 firms, and there's plenty of type 1 firms out there to serve them, right? So they're constrained to offer a combination that's at least this good, right? They don't have any incentive to offer something better than that, because why? They'd be giving away profits. So they're going to find a point where they make as much money as possible, which is where one of their indifference curves is tangent to this curve. This is pi 2 equals pi 2 star. Well, that's an indifference curve for the type 2 firms that corresponds to positive profits. That is, the type 2 firms are going to earn positive profits. Oh, shucks, I drew it the wrong way. Sorry. I drew a second consumer. They got to be tangent. They're looking like this. Good point. Pi 2 equals pi 2 star. I'm getting ahead of myself. All right, so it looks like that. They got to be tangent to that consumer's indifference curve. Look like that. So this would be Q star 2, P2 star. Okay? So that is, the consumers would be indifferent from buying from these two firms, and they would produce a higher quality in this example. They would earn positive profits. Somebody said they would earn rents. Exactly. They would earn rents on their superior ability, which is their lower cost relative to type 1 firms. Okay? Everybody understand that? Yeah. No. This isn't their cost curve. This is a positive profit curve. What do their indifference curves look like? That's a good question. What do their indifference curves look like? Let's think about it. How do we talked about the consumer indifference curves, right? Let's think about firm indifference curves. What do the firm indifference curves look like? Well, we know one indifference curve of theirs is their cost curve, right? C2 of Q. That is pi 2 equals 0. Everybody agrees with that? That is, the zero profit curve for these guys is just their cost curve. Because if they get a price equal to their cost, they earn zero profits. Right? So that's the zero. That we know that's one indifference curve, right? And that's the worst indifference curve we can get them on. Right? Any points down here earns negative profits. So these are positive. What do their indifference curves look like, actually, in this space? What does the pi equals $1 curve look like? How do you earn a pi of $1? You charge $1 more than this curve. So their curves are vertically parallel. They're just a bunch of vertically parallel curves, right? Now, that's a function of the fact that we assume they can only sell one unit of any quality. You could, in general, have a different set of indifference curves if you wanted. But, you know, for our purposes, that's good enough. So there's another indifference curve up here which has the same slope at every point, which is C2 of Q plus pi 2 equals pi 2 star, which is pi 2 equals pi 2 star, right? That is, you just add whatever that number is to the cost, and that's the indifference curve, right? So that's the curve that would be tangent here. That is, the zero profit curve would be down here someplace, right? Everybody, you see what I'm saying? Zero profit curves down here, they earn positive profits in equilibrium. Okay? Yeah.
So you can also have like a cost structure of, say, a third firm that ends up producing something at a lower price with less quality, but still make positive profits.
So there's nothing that says the only reason the guy who has more profits produced higher quality is because the way I drew it, his curve was flatter. If I had drawn this picture, C2 of Q, and this had been C1 of Q, but the consumer had been tangent down here, then I would have gotten the reverse case. I would have gotten the case where the firm earning positive profits actually was producing the lower quality product. There's nothing that says the firm that produces the higher quality product has to earn more profits. There's nothing in the economics that would tell us that. It's that this guy is better at meeting consumers' tastes, and his optimal way of meeting their tastes is meeting it with low quality. The other guy is if he's going to meet their taste, he's going to produce high quality, but because his costs are so high, that's actually consumers would prefer the low quality product at the other guy's cost. Okay? There's no reason it has to go one way or the other. Right? But these are the what we call inframarginal producers. That is, they're the producers who aren't on the margin of participating. These would be the marginal producers, right? The producers that are on the margin of coming into the industry. Okay? Now, in some problems, we kind of know who the low-cost producers are and who the high-cost producers are, because it kind of just comes directly out of the structure of the problem. And I'll give you an example later where it's pretty clear, once we set up the problem, who the low-cost producers are going to be. But more generally, it could be the low quality or high quality. Okay? Yeah.
So when there's too few type 2 consumers or firms to supply everything that the consumers want, then the consumers fall to the difference curve tangent to the type 1 firm cost curve, and
That's how we find the equilibrium, right? We sort of say, well, it's like you're searching for an equilibrium. You say, okay, look, the way I think about it is, these are the low cost types, they're going to survive. These are the higher cost types, and there are too many of them, so they're not all going to survive. So some of these guys got to earn zero profits. Once some of them earn zero profits, all of them earn zero profits. And if they're earning zero profits, they're on their cost curve, and then I know consumers got to be maximizing subject to that. They got to be tangent to that. And then the other guys got to be maximizing subject to the consumer's constraint, so they got to go in the other direction. But you see how that works? Okay. All right. So now what if we had multiple types of consumers and multiple types of firms? That's where we want to go next. And I think it's complicated, but I actually like to stick with the discrete case, at least for a while. So I'm going to assume there's two types of consumers. I'm going to have consumers are going to be A and B, and firms are going to stick with 1 and 2. So I got the same. And all right, back to my problem here. All right. So consumers and firms. Consumers are A and B, firms are 1 and 2. All right. So all right, now I'm going to make some assumptions that are kind of innocuous because I just want to define 1 and 2, and A and B. So 2 prefers high quality more than 1. Basically, in my picture, that means 2's indifference curves are always steeper than 1's, right? They always got steeper indifference curves. They're not higher or lower. That doesn't make any sense. They're indifference curves. Just whenever they cross, 2's are going to cross from below. They're going to be steeper. Yeah.
You mean like consumers have higher?
Oh, sorry. God, man. B's prefer higher quality than A. I'm really messing up on my notation today. B's prefer higher quality more than A's do. So that's going to define my B's. Okay? That defines my A's and B's. Now for 1 and 2, I'm going to make the following assumption. I'm going to assume that C2 of Q is less than C1 of Q. Okay? And I'm going to assume that C2 prime of Q is less than C1 prime of Q. This is a special case, and you can vary these all you want. So the idea is type 2 firms have lower costs than type 1 firms for any given quality, and they have lower marginal cost, which is kind of the picture I drew over there, right? I sort of assumed the 2's were the low-cost firms, and they were also the firms that would produce higher quality. Okay? Everybody understand? So the 2's cost curve is lower, but it's also flatter. Right? So like if the 1's cost curve, 1's look like this, 2's look like this. Right? They're always flatter, and they're lower. C1 of Q, C2 of Q. Right? That's my assumption. I'm assuming the 2's not only are lower cost, they actually have a lower marginal cost of quality. So they're lower average cost and lower marginal cost. You'll see it doesn't really matter. That's just part of the story. All right. All right. So now, let's think about it. All right. So does anybody see anything about the equilibrium already? And I'll assume that N1 plus N2 is bigger than NA plus NB. That is, the number of producers is greater than the number of consumers. And I'll continue with my assumption that N1 is less than NA plus NB, and N2 is also less than NA plus NB. Right? So that's my assumption. What is the import of those assumptions I just made? Right? This is going to restrict the equilibrium in kind of important ways. What would you say? All right, immediately I know, based on just those assumptions, a lot about this equilibrium. Yeah. So right, assuming this, so this tells us what? That one type of firm is going to earn 0 profits, right? That together with this means we know which one earns 0 profits. We know it's the ones earn 0 profits. This tells us both types of firms are going to have to produce in equilibrium, right? We're going to need both types, right? So we've kind of narrowing down the equilibrium here. We know 1, we know pi 1 equals 0, pi 2 greater than 0. Okay, we know that already, right? That's what we know so far. All right, so what else do we know? What do we know? Who's going to buy from the 2s? Who must be buying from the 2s in equilibrium? The 2s exist. Somebody's buying from them. Who must be buying from the 2s? Well, who wants quality more? Who's going to produce more quality? The 2s, they got lower marginal costs, so they're going to produce. Everybody sees why this tells us the 2s are going to have to produce the higher quality. Because if the 2s want to do it, if the 1s wanted to produce the higher quality, the 2s clearly would want to do it because they got lower incremental costs. Now, if you look on the demand side, you'd say if the A's wanted to buy the higher quality, then the B's would certainly want to buy the higher quality. So we know B's will, right? That is, the B's will buy from 2 for sure. Some of the B's at least. Who buys from the 1s? Well, somebody. A's will. All right. So the A's are going to have to buy from the 1s. So at least some A's are going to buy from the 1s. At least some of the B's will buy from the 2s. That doesn't quite completely determine the equilibrium, however. What else do we need to know? Yeah.
We at least need to know if there's more type 2s than B's or vice versa, right?
Okay.
And also, depending on that answer, I think you can do price discrete.
Well, that's not an. I've assumed this is a competitive marketplace, so we're going to assume you can't price discriminate, right? That is, you're not going to be able to charge different people different prices. That's an equilibrium outcome, not. It's not something exogenous we're throwing on the system, right? We're going to assume everybody maximizes profits. Consumers are free to move from one firm to the other. There ain't going to be any price discrimination in equilibrium, right? All right. You said the important thing, though. We need to know whether we know the B's will be there. We know the 2s will be there. So let's assume that NB is greater than N2. What does that tell me? That is, there are more guys who want high quality than there is high quality available. So what's going to happen in equilibrium? Okay. All right. So let's draw our picture. So here's our picture. Okay. So here's Q. Here's P. So what does our equilibrium look like? How am I going to find my equilibrium? Well, what do I know? I know I got to have zero profit for the ones. So I know that. So I got C1 of Q. And I know who has to be buying at least some from the ones. At A's. So I know Q1A, P1A. Everybody agree with that? That is in equilibrium. The ones are willing to supply any of those quality levels along that curve. The A's are going to choose the one they like the best. They'll go in and they'll buy that quality right here from the ones. Everybody agree with that? That's a point on our equilibrium. Now, we just said because of this, some B's are going to also have to buy from the ones, right? Remember, there's too many B's to only buy from the twos. So some B's are going to have to buy from the ones. So the B's, because they have a preference for quality, are going to have to buy up here, right? They're going to be somewhere else along that cost curve, right? They're going to want a higher quality, Q1B, P1B. That's where the B's are going to be. Everybody agrees with that? All right? So now, where are the twos going to be? Well, they have to be tangent to this indifference curve, right? Okay. All right. So this is pi 2 equals pi 2 star, right? That is where the twos are going to earn some equilibrium profit. Okay? And their equilibrium profit is going to be determined by their difference in cost, basically relative to the ones, and the type B type's willingness to pay for higher quality, right? That's really where they're going to go. All right? People see that equilibrium? All right. So that's it. We've determined equilibrium. The way I think about this equilibrium is I need to find my boundary condition, right? I need to find what pins down this market. And then once I've found where it's pinned down, I can use a series of indifference conditions to kind of get me to the solution, right? I know the ones got to sell to both types, so I know the ones got to be indifferent between here, and I know the B's have to be indifferent between the two firms, so it goes to here. So let's say I had 20 types of firms and 40 types of consumers, and I ordered them from the least quality preferring consumers to the most quality preferring consumers, and I did the same for the firms. I could follow this same logic. Everybody sees how I would do it. I would just match them up as I go. I would start out, I'd say, okay, who's going to match with the lowest quality firm? This guy. All right, well, if there's there's going to be some person who's indifferent between him and the next quality firm. And I would just chain all these indifference relationships together going up the curve. Okay? What would happen if we increase the number of twos to make it bigger than NB? How would that change my picture? I increase the number of twos. How would that change my picture? Yeah.
The profit is going to have to go down to match the A's if there are more A's than N1s.
So again, let's assume I still got both types of firms operating. I'm just going to increase the 2's to be bigger than the b's. So now all the b's are going to buy from the 2's. And so now the 2's have to now appeal to the a's. So they have to be able to compete for the a's, which means they're going to move to a profit curve that's tangent down here, right? That is, they're going to move to a pi 2 equals pi 2, call it hat, right? They're going to move down to a lower profit curve because they now have to appeal to these people who don't really like their product nearly as much as the B's did. And then the B's are going to be better off because they're going to now be tangent to this lower price curve, right? They're going to be tangent down here. So the B's are going to be better off because there's been an increase in the supply of people willing to consume, willing to produce the kind of products they like, right? There's more people willing to produce the kind of products they like, which are high quality products. Okay? People see how that works? All right? So that would switch the equilibrium. You can work through a bunch of examples, and it's always a good idea to do it. Now, what would happen if I switched it and I made it N1 plus N2 is less than NA plus NB? I'd have to bring something else in now. What else? What would happen now? Now what's going to happen? There's going to have to be some consumers who don't get served, right? In the previous case, it was some firms. So there would have to be some fallback utility that you get if you don't get the good. And one of these two types of consumers is going to have to get its fallback utility. That fallback utility curve would then be my starting point for my analysis, right? But I would still go the same way. The 1's would be stuck with the low quality guys. The 2's would be stuck with the high quality guys. The A's would be buying from the low quality producers. The B's would be buying from the high quality producers. But you'd still get a same indifference relationship. It's just my boundary condition would be determined by the B's, by the utility side rather than the cost side. Kind of corresponds to pi equals 0. No surplus from participating in the market because some people are outside, so the equivalent people can't get any surplus. Okay? Any questions? Now, more generally, if you had a continuum of types, that is, you have all kinds of different consumers and firms, what we're going to end up, now, one thing interesting about my equilibrium locus here is you'll notice, if we go back to my original problem, from here to here, we follow the consumer's curve. From here to here, we follow the producer's curve, right? Because that's who had to be indifferent across those two regions. This types of consumers, did I do that right? No, this one is across the consumer. Yeah, we're following the producer's curve because I had to induce the same producer to sell to two consumers. Here, I follow the consumer's curve because I had to induce the same consumer to buy from two different producers, right? That's why you have to follow one side or the other. If you had like a whole bunch of types on both sides, more generally, you end up with some kind of an equilibrium that looks like this. There's some P of Q function in equilibrium. And the consumers are tangent from below, and the producers are tangent from above, like that. And they're matched up. That is, there's a matching going on between the consumers and the firm, where the guys with the high cost of quality are selling to the guys with the low value of quality, right? The guys who want quality, don't want quality very much, buy from the guys who it's hard to make higher quality. And the same kind of equilibrium would occur. Again, there's like a boundary condition that sets this whole thing up, and then everybody sorts their way out up the curve. That's just a continuous version of what